Okay. The next one we're going to talk about is your chemical reactions. Where's the paper? Okay, we're going to talk about chemical reactions. Let me see, where's the end mark that you guys can see? In there? Okay. Not doing much. Okay, we got 5 types of reactions. You guys should all know these. The first we're going to do is a single replacement, which is Zn plus HCl. This is going to take the place of that one. Again, it's because this is going to, it's a metal, so it's always going to have a positive charge. It's going to replace the thing that's in positive charge. What's first is always going to be cation. What's second is always going to be your anion, or the one that accepts the electrons, okay? So in this case, you would have Zn. Now, remember that zinc, if you look at your polyatomic ion chart, it has a 2+ charge. So zinc is going to be 2+. We know that Cl is a 1-. So you're going to cross these, and you get ZnCl2 plus H2. And the reason we get H2 is because of Brinkelhoff, and that's saying that Brinkelhoff, which is like a name, these are all coming in twos. So these are diatomic molecules. They always come in twos, okay? So this would be, now, this would be your products here. Because this one replaced this one, and now this one is kind of left out in the cold, we call this single replacement. Or single displacement. Whatever. It doesn't really matter which way you want to look at it. Can you see it? Okay. Now, the next reaction that we're going to look at, we have HCl plus NaOH. This is going to be a double replacement. This is going to be a plus. Remember, this is a 1+ charge, this is a 1-, this is a 1+, and this is a 1-. This is because it's group 1, group 17, OH- because if you look at your polyatomic ion chart, hydroxide is minus. Alright, so plus with a minus, these two switch partners, and so your products are going to be NaCl and HOH, or water. This is a double replacement, or double displacement. Okay, what's next? CH4 plus O2. We have a carbon source, we have an oxygen source. This is going to be combustion, okay? So always in combustion reactions, CO2, H2O. Okay, always those are going to be your products. And remember, we need to go ahead and balance all these equations. So in order to balance this one, you would have, we know that we've got 4 hydrogens here, and over here we only have 2. If I put a 2 here, we have 2 times 2, which is 4 hydrogens. 2 times 1, we have 2 oxygens now, plus these 2, which gives me a total of 4. And we've got 1 carbon, so that's fine. So all we need to do here is put a 2 there in front of that O2 to balance out the fact we got 2 here, and 2 times 1, so we have a total of 4 oxygens. Combustion. What's next? Okay. H2 plus O2 yields H2O. We start with multiple products, we end up with 1. The fact that you end up with 1, this is a synthesis. Okay? Synthesis reaction. And if I take H2O2 and I break it down into H2O and O2, okay? We started with one thing, it broke down, this is decomp. Thank you, appreciate it. All right, so that is a decomposition reaction. Okay, so those are the 5 types. Next thing we need to talk about though, if I have an equation, so I've got my reactants, and I got my products, right? If I have to add heat, so if I put heat on this side, okay? You guys, go away, I'm trying to do something. All right, if you have to add heat on this side, then in order to get the reaction to happen, this is going to be an endothermic. Or if instead of heat, if you have to add, stop, I'm serious, it's not funny. If you have to add heat, or if you have to add, let's say energy, then it's an endothermic because the process isn't going to happen on its own. Can you see that? Yeah. But if I have my reactants and my products, Okay? And I have energy or heat over here. So we have heat. You could also say energy, because they're basically the same thing. This would be an exothermic reaction. And that's because it gave off energy. So it's going to kind of be more of a spontaneous reaction. It'll happen on its own. In order to do some of these problems too, the other thing that you need is your reactivity chart. Okay? Which I gave you two different ones. I'll show you this one here. Basically what this saying is, lithium is the most reactive. So here when we looked at our first problem, which was zinc and HCl in a single replacement, and you're going to use these mostly with single replacement reactions. You'll notice you have zinc here, and we have hydrogen. Where's hydrogen? Which is down here. So because zinc is more reactive than hydrogen, okay, make sure you guys can see where those are. Where's zinc? All right, so zinc is there. Because it's more reactive, it'll actually replace the H plus here in this reaction. So in order to do those, you have to look at your reactivity chart.